Hello, geometry folks. Today, we are going to talk about proving triangle congruence and the 4 congruence shortcuts. And then we're going to talk about 2 that are not congruent shortcuts. Alrighty, let's talk about them. First, congruence, what's that? That's geometry speak for equal. So we're looking for how do you prove that one triangle is equal to another triangle, has the same side lengths and has the same angle measures. All right, well, let's take a peek. Alrighty, so here we are, and these are our 4 congruent shortcuts. So this first one, these S's stand for side, side, side. And what that tells me is that if all 3 sides of one triangle are congruent to the corresponding 3 sides in another triangle, then I know that every side and every corresponding angle will also be equal to each other. Side angle side tells me that if I have side and then an angle and then a side where that angle ends up being in between those 2 sides. And notice in the name of it, side, then angle, then side, it tells you that angle has to be between the 2 sides. Then again, I have proven triangle congruence. And every time I prove triangle congruence, that means that every corresponding angle will be congruent and every corresponding side will be congruent. All right, here's the next one. Angle, side, angle. Again, look at the placement. That side is between those 2 angles, and visually same thing. An angle, a side in between, and another angle. Proves triangle congruence. And then finally, side, angle, angle is actually angle, side, angle in disguise. So take a look here. If I have 2 angles, then I also have that the third angle has to be congruent because every triangle adds up to 180 degrees. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then by the laws of subtraction, 180 minus equal things has to equal an equal thing. And then that means that I then have angle, side, angle. So side, angle, angle is actually angle, side, angle in disguise. Now, here are the 2 that do not prove congruence. Side, side, angle. Now notice before, side, angle, side, that angle is between, it is bounded by those 2 sides. Here, we have 2 sides, but we do not have the angle between them. We have an outside angle. That does not prove congruence. Sometimes it could be the case that these 2 angles are also congruent, in which case we have side, angle, side, and then yay. But it could be that these 2 angles are not the same. Similarly, angle, angle. Okay, well, as we discussed up here, that means this third angle is congruent as well, but I don't have any information at all about the lengths of the sides. So while these 2 triangles will be similar, they will look like kind of cookie cutters that fit into each other. They are not necessarily exactly the same size. They could be bigger or smaller versions of the same. So how do we use these? Well, let's take a look. So now we're going to ask ourselves, are these triangles congruent? And if so, by which of our congruent shortcuts? So let's take a look at this first one. We have a side that's congruent. We have another side that's congruent. But here we have the angle between them. Here we have a different angle. We do not have the angle between them. So we do not know that those 2 triangles are congruent. All right, over here, we have a side. We have this marking here, which means a right angle, 90 degrees. And if they're both 90, then they are congruent. And then we have a side. So we have side, angle, side. These are congruent by SAS. All right, over here, we have angle, and that's all we have. these are not necessarily congruent. Over here, we have side, side, side. Those are congruent by the SSS theorem of congruence. Over here, we have side, we have angle, but then we do not have the other side that bounds them. We do not have side, angle, side. We have side, side, angle, side, side, angle. So these guys are not necessarily congruent. All right, over here, we have side and another side and not the angle in between them. So these are the same actually. Nope, we don't know they're congruent. Okay, over here we have angle, and then we have a side, and then we have the other angle that binds them. So these are congruent by angle, side, angle. Over here, we have angle, and we have another angle, and then we have a side. So since we have two angles, that means we also have the third angle, and therefore we have angle, side, angle. And so these are congruent by angle, side, angle, or the original one, right, was side, angle, angle. Those are the same thing. All right, over here, we have a side and we have an angle, but we have something else. Remember that whenever two lines cross, they create vertical angles. That means that the angles opposite each other are equal. And if we put that into our picture, then we have angle, side, angle, angle, side, angle. So even though it didn't look like it at first, because it only looked like we had two elements, we actually have knowledge of a third element because of vertical angles. Okay, let's take a look over here. Well, let's note right off the bat that we've got vertical angles again. All right, so we know side, angle, side, that's one of our congruent shortcuts. All right, over here, it looks like we've got side, and we don't have enough information except hold the phone. Remember the reflexive property that says that something is equal to itself? So this side is in this triangle, and it's in this triangle. So this was a hidden SSS. Okay, over here, we have angle. We have another angle, and then take a look at that. That's a reflexive right there. So that's our side, angle, angle, or our little hidden. We know these two top angles have to be equal as well, so that could also be angle, side, angle. All right, over here, we have sides. We have a reflexive side, and that's all we have. That is not enough information. All right, over here, we have angle, we have angle, we have side. We know what that is, side, angle, angle. That's enough. Then finally over here, we have side, we have another side, and we have an angle that is not between those. That is not enough information. And so this is an example of lots of different ways to apply our SSS, our SAS, our ASA, and our SAA shortcuts of triangle congruence. Well, that was a lot, but I'm hoping that that leaves you feeling more comfortable with those 4 shortcuts of triangle congruence, how to analyze a picture and decide, is that angle or that side between those other 2 elements, or is it not? And then does that make it qualify for one of our shortcuts, or does it not? And then don't forget to look for hidden knowledge, like a right angle, all right angles equal all other right angles, like a reflexive side, or like a vertical angle that's giving you information even without being written on the page. All right, have fun playing with these triangle congruent shortcuts, and keep on mathing.